this next section is a summary of all of the mathematical elements that you're going to need to come to grips with and be conversant with in the material that you're going to have to study for the exam. This is the most, in fact, it is the only place where you're going to get a bit of math, but not to worry. Once we're done with this afternoon, that's it. That's the sum total of everything that we're going to do regarding mathematics. And just as a heads up, this is an area which, doesn't feature that highly in the exam. It probably ranks at most about, you might have up to 6 questions in your entire paper that have calculation that you're going to have to work out. And that is when you literally have to use a pen and paper to kind of figure out the answer. There will be some obviously high level things where you got to do some judgment of, is this one greater or bigger or less than something? And I'm not talking about those. I'm talking about where you have to literally do a calculation on a piece of paper. At most 6 questions. So this section comprises earned value, network diagrams, and project selection and feasibility. We've got various numbers of questions here. Please ignore this slide. As I say, you can basically chop each of these numbers in half. So between 2 to 3 calculation questions that are earned value, 1 network diagram, and possibly 1 on project selection or feasibility. It's more or less half of these values now. These numbers that we have here are numbers that applied literally last year. So they have been chopped in half, more or less. So in terms of earned value, this falls under the cost management area. Here we have an analysis of a given project. We have a statement that comes from one of the project managers that we're responsible for. So if you are a program manager or portfolio manager, one of your project managers submits this report, how do you respond to them? If they come to you and they say, look, we were planning on having a certain cash flow, and that's represented by the blue line. So we thought we were going to spend this amount of money over the time, but we're sitting here on the 8th week at the moment. So we're sitting over here at this point, 8th week, right there. And we have an actual cost, which is way below what we had planned. And if I were to ask you, is this good or bad, what would your response be? So our planned value was we would spend over 100,000, looks like about 120, 125. And we've only ended up spending 60. So who would like to venture an analysis of whether that's a good or bad thing?
It appears to be bad.
Appears to be bad?
It can be good or bad depending on the other factors that you have to evaluate.
Okay, so what other factors would you be looking for?
Work completed.
Excellent, very good. We want to know how much work has actually been completed. In other words, how much forward momentum do we have on the project? Have we got deliverables that we were planning to achieve by week 8? Have we got all of them? If we have got all of those deliverables that we were planning to achieve by week 8, and we've managed to spend less than we planned, then it seems like everything is good. Would you agree with that? However, if we've only achieved, say, a quarter, one-fourth, 25% of the deliverables that we planned, and we ended up spending that amount, what would you say about that?
Hi, Philip, can I ask?
Yeah, go ahead.
Yeah, look, I agree that, if you spend less, it means, quite a number of lines were not delivered. But however, what if you spend less because most of the items you bought them at a discounted rate together with labor? So there were some good negotiations there, but quality was good.
Okay, we won't be talking too much about quality. We're just looking at cost and time at this point. So yes, exactly as you say, what happens if we manage to get things at a good discount? That is a good question. So I think the missing piece out of this diagram that you're looking at here is we do not know what percentage of the
progress.
deliverables that we should have delivered have actually been delivered at this point in time. We don't know that. And because we don't know what we should have delivered by this, well, we know what we should have delivered, but we don't know how much has been delivered. We don't know the dollar value of the items that were expected to be delivered by this point in time. We know we expected to deliver about $125,000 worth of deliverables. We know that we've spent about $60,000 in the acquisition, but we don't know how much deliverables have been produced. That's what we don't know. And that's the part which is missing out of this graph. We want to be able to go on site and count. If we're building a house, we want to count how many walls have been built, how much of the roof has been put up. We want to count those things that are done. And we want to compare that with what we, and add up and get a dollar value for all the things that have been done and completed. So earned value management integrates and combines measurements of scope completed, time passed, and costs incurred. So we use this for reporting on project performance and also for forecasting problems with performance. It integrates three things: the scope baseline, the schedule baseline, and the cost baseline. The scope baseline, you can think of that very loosely as the scope WBS, the work breakdown structure, although it does also include the scope statement and the WBS dictionary. Those three things together comprise the scope baseline. So it takes the scope baseline, it combines it with the schedule baseline, which you can think of as being the master schedule for your project and all the dates and times that you've allocated for each of those activities, and the cost baseline. Cost baseline, which would be your set of estimates which have been finalized, and you now have your detailed costing that everybody is aware of because you've published this. This is what we're aiming at. So it integrates these three baselines into a single measuring stick called the performance measurement baseline. So consider a situation we are making some hats, and in our hat making process, we are halfway through. We want to make 10 hats. Each hat is 100 Rand each. Right now, where we are at this point in time, we are at the point where we should have produced 500 Rands worth of hats or 5 hats. The yellow line is what we have produced. This is the missing piece from the very first slide where we had our ideal or our projected value of what we should achieve, and we had our actual cost. But we didn't have how much of the deliverable was produced. This yellow line here is the earned value, or the line which represents the amount of deliverable that is being produced up until this point in time. So we have 4 hats that have been produced. According to our performance measurement baseline, we should have produced 5 hats by this point in time. So if we should have produced 5 hats, but we've only produced 4 hats, what does that tell us? Anyone?
You're behind program.
Sorry?
You're behind program. If you
Excellent.
produced 4 and the cost is 4, that's fine because the cost for 5 was 500. So you're behind program.
Excellent. So if we should have produced 5 hats, but we have only at this point produced 4, it means we're 1 hat late at this point. Or we're 100 Rand behind schedule in terms of the production of deliverables. We're 100 Rand behind. And that calculation is basically just taking the planned value at today's date, which is 500 Rand, and we subtract that from our earned value. So our earned value is the yellow line, which is 400, and subtract from the 400, 500, and 400 minus 500 is negative 100. So our schedule variance, or SV, this value over here, this one here, is our schedule variance, is our earned value, the yellow line, 400, minus our planned value, which is 500, giving us a value of negative 100. If we have a negative variance, that is a bad thing. It means that we are, in this case, late. The next piece of information that we get given on this project is that we have an actual cost of 600 Rand. I don't know if you can see that red line that has now come in, that red dotted line cuts across at the 600 Rand line for the present tracking date. So we get the data from our accounts, the project accounts department. They tell us, look, you've spent 600 to date. So you paid for 6 hats, but you've only received 4. That means that we've spent 50% more than what we've expected to spend for the number of hats that we presently have in our hand. So I'm not sure if it's because we're giving kickbacks under the table to someone, or that we've got a whole bunch of materials that we've bought that have not yet been assembled into hats. Probably the latter. We probably paid for materials that have not yet been manufactured and put together into the hats. Let's hope for the best in that. Right, but at this point, if you just look at it straight head on, we have a cost variance, which is the distance between the present earned value, which is 400 Rand, and what we've spent. So the amount of hats we have is 400 Rand. The amount we've spent is 600 Rand. So 400 minus 600 is negative 200. We have overspent on this project at this point by 200 Rand, or by 2 hats, or by 50% of the hats in hand. Because if we have 4 hats in hand, half of 400 is 200, which represents the overspend at this point in time. I'd like you at this point to take your exercise, go to the back of your book. Actually, not the back, it isn't completely the back. It's actually page 2. Just getting the right place, 2.30, or is it 20? Yeah, 2.23. It's this part here. Okay. So open up this page in your notes. And let's read together. A project is underway to install 100 new air conditioning units in a building. Halfway through the project, 50 units should have been installed, but only 35 are complete. In the table below, indicate which items correspond to earned value. That earned value is 1, planned value is 2, budgeted completion is 3, and percent complete is 4. Now count the empty blocks in the table below the question mark. There's 1 empty block, 2, 3, 4. There are 4 empty blocks. You need to take the 4 bolded items above in the paragraph and put each one of them on their own line in the table. So decide whether you want earned value here, 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 or here, and write it in, please. And then once you've written earned value, then go to the next one, planned value, and decide where you're going to put that. I'd like each of you to be doing that now. Please go ahead, even if you have to just take a piece of paper and a pen and write down, draw a little table and write down project budget, planned progress, work to date, progress to date, and then just say whether it's earned value, planned value, completion, or percent complete. I'm going to give you 2 minutes to quickly do that. You got the correct answer they'd like to read out. Please go ahead.
Okay. It's Musa here.
Yes, Mr. Yeah.
Okay, number 1, project budget. It's linked with budget at completion.
Very good.
100 accounts. And then number 2, which is planned progress at 50 units. That is a planned value.
Good.
And then number 3, work done at date to date, which is the end value.
Very good.
And then number 4, progress to date. That is the percentage complete. of
Well
the
done, Musa. You got 100% for that. Good job. Right, so let's go on to the next one below this, which is the slightly more advanced on the previous idea. So indicate which items below correspond to earned value, comma planned value, comma actual costs, comma budgeted completion, and estimate at completion. You'll notice that there are 5 of those items. And if you count the cells in the table, there are 6 cells, which means one of those items you're going to put down twice. You pick which item it is that you're going to put in twice. Okay, but let's go over that. Who has confidence that their answer is correct? Somebody other than Musa, please.
Hi, Philip.
Hey, Muriel, go ahead.
Yes, the first one, I have it as budget at completion,
Very good.
revised final cost, actual cost.
Perhaps not. Let's strike that one. Keep going with the third one.
The planned cost to date, planned value,
Very good.
value of work done, end value,
Well done.
value of work done to date. It's estimated completion.
Let's strike that.
Okay, spent to date is actual cost.
Correct. So there are 2 that you got most of them. There are just 2 that I said we would strike, and that's the second one and the fifth one. Is there anyone else that can give a suggestion for the second and fifth item?
Yes.
Philip Hendrik.
Okay.
Yes. Go ahead.
So the second one, estimated completion.
Correct.
And then the fifth one is again earned value.
Correct.
Yeah.
So you can see from the 4th and the 5th, they both start the same way. Value of work done to date. The 5th one is also value of work done to date. So they are the same item. It's just calculated using a different method. That's all. That's the only difference between the 2. You're coming to the same numbers at the end. Okay. Well done with that. Right, so let's move on. So, you know what, actually, in terms of the time, I think we're at the point where we've gone over our 45-minute limit. And so I think we should take a short break. Let's take a 10 to 12-minute break, and we'll reconvene again at about 22 minutes past. Thanks very much. See you in a moment.
Thank you.
Yeah.
Great. Let's continue where we left off. We're talking about the variances, and we're just revising what I've already mentioned to you. So we'll first look at the schedule variance. So the schedule variance is the difference between the earned value, which is the product that we have in hand or the deliverables that have been done, minus the planned value or the deliverables that we said that we would do by this point in time. So in the case of our example, we have received 400 rands worth of deliverables, which is the earned value. And we said we would have 500 rands worth of value by this point in time. So 400 minus 500 is negative 100, which gives us a schedule variance which is less than 0. So that means the project is behind schedule. From a cost perspective, the cost variance is the earned value minus the actual cost. The earned value at the moment is 400 Rand. The actual cost is 600. So the cost is 400 minus 600 is negative 200. So that is less than 0. And so that gives us a negative number, so which, based on our slide that you're looking at, the project is then over budget. We have overshot our budget. We have spent more than we had planned. So basically a negative result, a number that is less than 0, is a bad result. A positive number is a good result. However, if you are comparing two different projects, so let's, as a program manager, you have more than one project manager that you're working with, and you're wanting to be able to compare two projects with each other. They're both late. The one project is late by 100 Rand, as you can see here. The other project is late by 10,000 Rand. Okay, which one is more late? Which one is further, and which one is a greater issue? Well, it all depends on the numbers that we're working with, and so the variance is not helpful at all to say how bad it is. And so we turn to another calculation in order to see the severity of the problem, and that is the performance indices, the schedule performance index and the cost performance index, where we have the same two dimensions that we're looking at, schedule and cost, but instead of subtracting these variables, we're now dividing. So instead of saying earned value minus planned value, we now say earned value divided by planned value, instead of for the schedule performance index. Instead of saying earned value minus actual cost, we now say earned value divided by actual cost performance index. So in the example that we have here, that we've been looking at, our scheduled performance index is the earned value divided by the planned value. The earned value is 400 Rand. The planned value is 500 Rand. So 400 divided by 500 is 0.8. 0.8 is less than 1. So if you look at the 3 lines below the box, you'll see that if we have an SPI of 1, then the project is perfectly on schedule. If it's less than 1, in this case where we have 0.8, then the project is behind schedule. If the number is greater than 1, then the project is ahead of schedule. With our cost performance index, it's equal to earned value divided by actual cost, which is 400 divided by 600, which is our actual cost. 400 divided by 600 gives us a value of 0.66 recurring, I think. And that is a CPI, or cost performance index, less than 1, which means the project is over budget. So if we have a value of SPI or CPI that is less than 1, that is bad. If we have an SPI or CPI that is greater than 1, that is good within reason. There are values of CPI and SPI greater than 1, which start to become again a negative issue, but that's, I'll get into that in a moment. If we have an SPI or CPI that is exactly equal to 1, it means we're perfectly on target for that particular item that we're looking at, whether it's the schedule performance or the cost performance. Now, I mentioned that if the SPI or CPI is starts trending towards a very large number, like for example, if your SPI or CPI was 1.5, we're starting to get into territory where that represents a bad thing again. Now, on this slide, it says if the SPI or CPI is greater than 1, that's a good thing. And in general, yes, it is a good thing. However, if you have a number that is starting to trend towards 1.5 or above, what it begs the question is, why is it that your SPI or CPI is so high? Surely that indicates that you haven't done very good planning originally. If your SPI and CPI is so high, we could have done better things with your time and money, and you could have allocated the money that was available for this project to something else. So there's a bandwidth within which a performance index should fall in a practical situation. Here we have an example of an earned value table. On the left-hand side, we have various deliverables or items that need to be done on the project. And we have the budgeted completion value, how much we intend to pay for each of these items or deliverables that needs to be done. Then we have the percent complete. We then have the AC, or the actual cost. This is the cost that has been spent thus far. We have the planned value, what we plan to spend, and the earned value. The rest of the items to the right of that, the EAC, CV, SV, and completion variance, are all calculations. How do we calculate them? How do we figure out what the EAC is? How do we calculate what the CV, SV, and completion variance is? Well, you know how to calculate the CV and SV. CV is calculated as, help me with this. How do we calculate cost variance?
EV minus AC.
And yes,
Very good, EV minus AC. How do we calculate schedule variance?
EV minus PV.
minus PV.
EV minus PV, very good. And how is the EAC calculated in this case? If you look at what's going on here, what is it?
Is it
If
BAC divided by CPI?
What is your CPI?
That would be EV divided by AC.
EV divided by AC. Yep, it could be something like that. Well, let's.
I'm not sure.
take it
I'm
as
not sure of
given
the
for this
condition
data.
currently. Sorry, I'm not sure of
Yeah,
the
so
condition.
there are multiple methods in which you can calculate EAC, and for the purposes of this particular slide, let's just ignore that. How's the completion variance calculated? That is a calculation which you can look at and derive directly from the slide. It's your BAC minus your EAC. Do you see that? So your completion
Yes.
variance is BAC minus EAC. Right, we're now on to the next exercise. So go to your exercises at the back of your book. And this is the next one that we're doing. Using the table below, calculate the earned value parameters for the construction of the Mars rover Curiosity. So we need to go and calculate the PV, the EV, the CV, the CPI, the SV, and the SPI. Would you like to do this within your teams, your breakout teams?
Yes.
You would, okay. Right, I'm going to open those rooms for you guys, and then you can go ahead and do this as a group. I'll give you about 5 minutes to do this part 2.1, and then I'll pull you back. Vinay, which room were you in?
I'm currently driving from Matuba, so I'm gonna just check
Okay.
in with these guys. Yeah, I've got you in my earphones, yeah.
Okay, so which room were you in previously? Do you recall?
I joined in late, Philip, so I wasn't in a room.
Okay, so I'm going to post you then into one of the rooms. Hey guys, how was that? You finished?
Yes, finished.
Yes.
Yep, you finished. Hey, who did not finish?
We didn't finish.
Okay, no worries. So what I'll do is I'll post you back into your groups for another 3 or 4 minutes. And for those of you who have finished, you can continue on 2.25, where you look at 2.2 and you analyze the graphs. Let me show you what I mean by that. So it's this part here. at the top of 2.25. So you basically look at this graph and you say, is it running ahead or behind schedule? Is it ahead or over or under budget? And you define that for each of these items on this page. So those of you, that is those of you who have finished the previous exercise. For those of you still carrying on with the exercise, try and finish this within 2 or 3 minutes, and then you can carry on with this. I'll pull you all back in about 4 minutes time. Thanks. So we're now on to the topic of earned value forecasting, and we're trying to determine what the amount of money is that we're going to end up spending at the end of the project. So if we look at this example that we've been tracking with thus far, so at the tracking date, we have spent 600 Rand when we should have only spent 400. If we carry on at this rate of spend, where we're spending 50% more than what the product is that we have in hand, and if the BAC for the entire project is 1,000, then it looks very, very much as though if we're continuing spending at the same rate, that we're going to end up spending 1,500 by the end of the project, because half of 1,000, which is our BAC, is 500. If we add that on to the 1,000 BAC, we'll get 1,500. So that's the logic for this particular graph that we're looking at. So there are multiple ways of deriving and forecasting what we will end up spending. The most accurate way of forecasting the spend till the end of the project is to go back to the people who are going to be doing the work and getting them individually to estimate what the costs will be, and to then sum those individual costs up. That's the most accurate way. Go back to the people who are doing the job and individually and get their estimates, each one of their estimates, and add them up. So there's our BAC, there's our EAC, and the difference between the two is the cost overrun. We have our estimate to completion, which is, and this is wrong on your slide, please correct it. It says on the slide EAC, it should say ETC, estimate to complete. Apologies for that error. So you can see on the sideways writing, it has the letters EAC, it should be ETC. Please correct that. So assuming that work is proceeding on plan, the cost of completing the remaining work can be calculated as ETC is EAC minus AC. So long as we are assuming that we're continuing to complete based on the projected estimated completion, we'll end up spending the EAC minus AC, the cost that has been spent to date. So we have here the 4 different methods of calculating the EAC. I've already mentioned the first one. EAC is the actual cost plus the bottom-up ETC, where we go back to the people who are doing each one of the items and ask them what their best estimates are, sum all of those up, add them to the costs that have already been spent, and that is our new estimate at completion. It's very detailed, and it's actually quite accurate, more accurate than the other 3. If you aren't able to go back to those people and get those estimates, there are 3 ways of calculating the EAC. And these 3 common methods for EAC forecasting are using the budgeted rate. So in other words, if we say that we accept the fact that we made a mistake in our example where we've spent 50% more than we intended to, but we say, look, for the remaining hats that still have to be made. So if we go back to our example, you will recall we have 4 hats in hand, so we have 6 hats that are remaining. We spent essentially 150 Rand per hat for each of the hats that we currently have in hand. How do I know that? Because the actual cost is 600, and we've only got 4 hats in hand. So that means we ended up spending 150 Rand each. So for the remaining hats, the remaining 6 hats that have not yet been made, this here, which says performed at budgeted rate on the right, this calculation is saying, look, we'll call the actual cost or a sunk cost. It's already gone. We've spent it. So the 600 Rand is already spent. But the remaining hats that still have to be made, we'll say that we'll do them at 100 Rand a hat, the original agreed upon rate. We originally agreed that we were going to pay 100 Rand a hat. So we have 6 hats left. So those 6 hats are then going to be added to the actual cost that we have already sunk or spent. So the BAC minus EV is the 1,000 Rand minus the items that we've already done, which is 400 Rands worth of value, which is the 600 Rands worth of hats that still need to be produced. We take that 600 that still needs to be produced, added to the 600 Rand that's already been spent. 600 plus 600 is 1,200. So if we use that method, we're going to come up with an estimate at completion of 1,200 Rand. The next method says we're going to work at a rate that assumes that the present trend will continue. Now, as I've already mentioned, we're at present spending 150 Rand a hat. So if we do this ongoingly, then we know we have a BAC of 1,000. So that was our budget completion. We were aiming at 10 hats. So if instead of spending 100 Rand a hat, we spend 150 Rand a hat, then our estimated completion is going to be 10 times 150 Rand, which is 1,500 Rand. So that next option, the second of the lower 3, will then be a total of 1,500 Rand. And then the last option is calculate the EAC and consider the costs that have been spent already sunk and spent. They've already gone out. So we accept the 600 Rand that has been spent. We look at the remaining work that needs to be done. That's BAC minus EV, which is the 600 Rand that remains to be spent. But now we factor in both the lateness and the overrun, both factors. So the lateness factor is a number which is SPI, which is equal to 0.8. Okay. The overspend is your CPI or cost performance index, which is 0.6 remaining. So 0.666 times 0.8 is very roughly about 0.5, roughly a half. Is that right? 0.666 times 0.8. Yeah, it's around about 0.4849. Call it 0.5. So it's a half. Okay. So if we have a half underneath the line there, and we have 600 above the line, you can invert and multiply it. That would mean that we're taking 600 and multiplying it by 2, which is 1,200, and adding the AC to it, which is 600 plus 1,200 is around 1,800. So this EAC is going to be very roughly 1,800. So of these 3, the top EAC is going to give us a value of 1,200, the middle one a value of 1,500, and the bottom one a value of 1,800. So when we consider both the CPI and the SPI, it jacks the number up, especially if we're late. Great. Now, this slide I've seen this used on an exam question before, where they give you a scenario, and then they say, based on the assumption that we will continue to spend at the budgeted rate, what is the estimate at completion? So they will give you the right-hand column on this slide. So that the fact that your CPI will continue at the current trend and that the performance will continue at the same rate with the current costing. So what would your EAC be in that case? And then you need to perform a calculation based on the way in which, or the assumption of how the costs are going to continue to be spent. Do you have a question, Hendrik?
No.
No question, okay. Okay, so do you understand how this particular slide can be examined? So they put out a question, they say, this is the EV, this is the AC, this is the PV, this is the EV, and then they say to you, okay, what is the EAC assuming that trends continue, that the current cost overruns continue? Then you plug in the numbers into the formula and you work it out and pick between A, B, C, and D.
Do you have a place, Philip, where you put these values so that we can remember at the later stage?
Are you asking for a single sheet which has all the calculations on it so that you can memorize them in one shot?
Sort of, yes.
Yeah, sure. We do have something like that. In fact, it may even already be in your book, but if it's not, I will send one to you. I'll either point you to the page in the book or I'll send you one.
Okay.
Okay, let's move on. All right, so the next part is to do exercise 2B, which is beyond the part that I've given you for an assignment. It's page 2.26. Let me just get that up for you so that you can see what that looks like. So there was the stuff that you've been assigned for that you can hand back to me, 2.2 and 2.3. It's the next section, exercise 2B. And so what this is to calculate the EAC for question 2.1 using three different methods, these three different methods here. So going back to this table here, just add in 3 columns to the right of this for each of the 3 different methods of calculating the EAC, and then calculate the EAC based on these 3 methods down below here. Okay, right, so I'm going to post you into your groups again in order for you to go and do that. We're busy with network diagrams and we're looking at deriving the float and the critical path. Now, critical path method is not the only method that is out there for working with networks and looking at calculating float, but it is certainly the most used method out there, and certainly the method which, in terms of any calculation, will be the method that is selected in the exam. As already mentioned, the likelihood of you getting a network diagram question is probably you'll have 1 or at most 2 questions on network diagrams. I have had people come back and say they didn't get a single network diagram question at all within the exam. Right, so critical path method analyzed by doing forward and backward paths used to calculate early and late start and finish dates, float and critical path. It's the basis of all scheduling software tools. That is not true. Of 99% of software scheduling software tools, NetPoint, which is based on a method called GPM, graphical path method. Understanding that this is valuable for a planner to understand both critical path and float. So here's an example. We have a schedule for building a house. We're going to clear the site, then we're going to do the foundations and floor, then the walls and roof. And at that point that we get to the walls, it's going to split 2 ways. It's going to go to the roof on the one side and the plumbing on the other. And then we're going to do some more things, electrical, plastering, windows and doors. And finally, everything is going to come together in the painting and tiling. So that list of activities, when you draw it out on a network diagram, looks like that. We have a bunch of boxes. Each of the boxes is an activity. And inside the box, you can see that there are smaller little boxes along the top and 3 little boxes along the bottom. And in the top right-hand corner of this slide, you can see the legend over here. That legend will explain to you what each of the numbers is in the boxes that you're looking at. So in the top left-hand part of the box, that is the early start. In the middle at the top, that is the duration. And on the right at the top, that is the early finish. Now, some of you have done network diagrams before. Perhaps you have done this, for some other course, or perhaps you've done it at varsity or for some project management degree that you have. And you were taught using the British method, which is that we start at 0 on the first network diagram box. So we have clear sight, and in the top left-hand corner, you would have put a 0 there. Please note that PMI is using the American method, and instead of starting with a 0, they start with a 1, and they work it like this. So you start with 1 and imagine now that it's the first day on the Monday in the morning. You work for 5 days, and that 5 in the early finish is Friday in the evening. And we'll carry on with the second box, the foundations and floors, on the 6th day in the morning. And so the calculation method to derive the early finish is to say, take the early start value, add the duration, and subtract 1. So starting in the first box, 1 plus 5 is 6, minus 1 is 5. So that 5 then gets plugged in the early finish date. We then move to the next box. In order to get the value for the beginning of the next box, we would add 1 to the early finish of the previous box. So the beginning early start date for foundation and floor will be the early finish of clear sight, 5 plus 1. So it starts at a 6. We now have 6 plus 15 is 21, minus 1 is 20. That gives us the early finish date for foundations and floors. In order to get the early start date for the wall, we say 20 plus 1. 21 plus 15 gives us 36, minus 1 is 35. And we now have 35 as the early finish date, meaning that the roof and the plumbing, which is where the network splits, will both start with an early start date of 36. You'll notice that as we move from roof to plastering, there's a minus 5 below that. That minus 5 is a what do you call it, a lag, a negative lag. And so what we should have had, if we hadn't had that minus 5 between tasks 4 and 7, between roofing and plastering, if we didn't have that, then task 7 would have started with an early start of 51. However, because that 5 exists, we subtract 5 from the 51 that would have been in this box right here. So that 46 would have been 51. But because of this minus 5 below here, we have to subtract that minus 5 from the notional 51 to give us 46 as an early start for the plastering activity. Does that make sense to everyone? Okay.
Yeah, sorry, Philip.
Yes, Sutani?
Passing PMI SP the first time by Peter Rogers, they used a slightly different method. They don't add that 1. For instance, if you go back to activity 1, clear sight. So you've got the late finish at S5, but then when you move to, obviously, what they do, they will carry over the 5 and they put a 5 at the early start of the next activity. So I just want to check for the exam, how does PMI interpret this in this manner? Because if it is this manner, I prefer this manner. It's much simpler to understand that the next activity will definitely start on the following day because you finish by close of business on the previous day.
Okay, that's a good question, Sutani. And I think also in the method that you have just cited, they also start at 0.
Yes.
Yes. So that's the alternate method. There are 2 methods of calculating network diagrams. I think it's possibly a good idea to be familiar with both. However, certainly in the PMP exam, the method that they're going to be expecting you to use is this method that has been displayed.
Thank you.
Let me just see what Yanga has just said. Can you please explain again from the split from the walls? Okay, so we have the walls, activity 3, which has a early finish date of 35. So ordinarily, one would start with a single activity after that, which begins at 1 plus 35, which would be the early start of 36. Okay, because you have a split, if whether that split is in 2, in 3, in 4, or in 5, all of the elements that split from there will have an early start of 36. Okay, so we're now going to track along the top chain, the roof, plastering, windows, and doors. And so we have 36 as the early start. We have a duration of 15. So 36 plus 15 is 51, minus 1 is 50. That's the early finish for the roofing. Now, ordinarily, in order to derive the early start for plastering, we would just say 50 plus 1, which is 51. However, because we have down below here a value of -5, because of that -5 down there, we must take the 51 that we would have put in the top left corner of box 7 plastering, and we need to subtract 5 from that 51, which gives us the 46 that you see there now. So that 46 is there because of the -5 down below between boxes 4 and box 7. So we have the 46 as the early start for plastering. We add 15 to that. That gives us 61. Subtract 1, which is 60. So 60 is our early finish for plastering, which then will cause the windows and doors to start at 60 plus 1, which is on the morning of the 61st day. For the windows and doors, that is our early start, plus 10 would give us 71 minus 1, which gives us an early finish of 70 for the windows and doors. Let's pause that chain and we go down below to the bottom chain. We start the plumbing activity 5 at an early start of 36, plus the 10-day duration for plumbing gives us 46, minus 1 gives us an early finish for plumbing of 45. 45 plus 1 will give us the beginning date for, or early start date for box 6 electrical. 46 plus 15, which is the duration, will give us a total of 61, which is the minus 1, which is 60, which is the early finish for electrical. We now have 2 boxes at the end of a chain. We have windows and doors up in activity 8, up at the top, ending with an early finish of 70. And we have the box 6 at the bottom, electrical, ending at an early finish of 60. 70 at the top, 60 at the bottom. Which one do we go with? We go with the largest of the 2 when we are doing the forward pass and we're joining the chains. So that's just something to memorize. When you're doing the forward pass and you're joining the chain, you take the largest of the 2 values. So 70 is the one that's going to drive that. If you want to work it out from an understanding point of view, imagine for a moment that we took 60. Okay, if we took 60, then painting and tiling would effectively be starting at day 61. Would that be possible? No, because it is then starting before the windows and doors have finished, which doesn't seem logical. Okay, we want the painting and tiling to finish after, or to start after both windows and doors and electrical have finished. So painting and tiling then begins at 70 plus 1. It has an early start of 71, plus the 15-day duration gives us 86, minus 1 is 85. So the early finish for the entire project is 85 days. Are there any questions with the forward pass from anyone?
Philip, not a question. I think just for clarity, I don't know if that's maybe what Jan was worried about, is that the -5 lag is due to the fact that you could start plastering before you complete the roof item. So it's just some info there.
Yes, well pointed out there. Precisely the point. So the plastering will start 5 days before the roof is scheduled to end. Good point. Great. If everyone's happy with that, we'll go with the backward pass, because this was the forward pass. Right, with the backward pass, what we do is we take the early finish at the top of activity 9, the number 85, and we copy that down to the late finish of activity 9, painting and tiling. So we now have a late finish of 85. We're now going to calculate in reverse to get the late start. To get the late start, we say late finish minus 15 plus 1. So we say 85 minus 15 gives us 70 plus 1 gives us the late start of 71. We now have 71 to calculate the late finish for both activity 8 and activity 6. We would say take 71 and we would subtract 1. So taking that, we have now 70 as the late finish for both windows and doors and electrical. Let's go along the top. Actually, no, let's start with the bottom. Starting with the bottom, we have a late finish for electrical at 70 minus 15 gives us 55 plus 1 gives us a late start for electrical of 56. Subtract 1 from that will give us the late finish of plumbing at 55 minus 10 gives us 45 plus 1 is 46, which is the late start for plumbing. We now go back up to the top for the windows and doors, and we say 70 minus 10 plus 1 gives us a late start of 61 for windows and doors. Minus 1 gives us the late finish for plastering of 60 minus 15 gives us 45. Plus 1 will give us 46 as a late start for plastering. Normally and ordinarily, if we didn't have the minus 5 there, that 46 as a late start would have rendered or given us a 45 as a late finish for roof. But it's not going to be 45 because we are now moving backwards, so we have to subtract. So we say 45 minus 5. So when we minus a negative number, we need to add. So 45 minus 5 is 45 plus 5, which is 50. We now have roofing at 50 for our late finish. Minus 15 gives us 35 plus 1, gives us a late start of 36 for the roof. We now have a late start of 36 for the roof and a late start of 46 for the plumbing. We must choose one of these to key off in order to calculate the late finish for the walls, activity 3 to the left of that. So which one do we pick? Do we pick the roof or do we pick the plumbing? Do we pick 36 or do we pick 46 in order to key off for our late finish in the walls? And the answer is when we're doing the backward pass, when we're working from right to left, then we key off the smallest of the two when the chain is joining again. Again, you can just memorize this, or you can do it from first principles by assuming the opposite one and coming up with a contradiction. So if we assume that plumbing is the correct answer, then the wall would have had a late finish of 45. If walls had a late finish of 45, it would mean that it's happening at the same time that the roof is still happening, which is not what we want. We want walls to be finished before roof and plumbing begin. Okay, so that's why we then pick the smallest of the two. We go with 36. 36 minus 1 gives us a late finish for walls of 35. 35 minus the duration for walls of 15 gives us a late start of 20 plus 1, which is 21. Because we have a late start for walls of 21, we subtract 1. That will give us a late finish for foundations and floor of 20. Minus 15 plus 1 will give us 6 as a late start for foundations and floors. Minus 1, so 6 minus 1 will give us 5 as the late finish for clear sight. Subtract 5 from the late finish, and that will give us a late plus 1 will give us a late start for clear sight of 1. Now, To check that your calculation is correct, what you need to do is you need to exclude the part where the chain splits. Look at everything on the left and right, and the early finish, the early start and the late start must be identical. Early start must equal late start, early finish, late finish, early start, late start, early finish, late finish. So that works pretty well. Just to highlight it here, so that 1 should be equal to that 1 below there, which it does. That 5 should be equal to the 5 below that, and it does. That 6 should be equal to that 6 below there. That 20 should be equal to that 20 below there, and so on, up until that 35 should be equal to that 35. We now exclude this section, which is the split. We exclude the split, and we now go to the other side. 71 is equal to 71, very good. 85 is equal to 85. So this is just a cross-check to make sure that we have done our calculations correctly. Right, now we come to the reason why we did this forward pass and the backward pass. And the reason for doing the forward pass and backward pass is in order to calculate float. So let's look at what the floats are. How do we calculate float? Float, very simply, is we take the late finish and we subtract the early finish from the late finish. So 70 minus 70 gives us a float of 0. 60 minus 60 gives us a float of 0. 50 minus 50 gives us a float of 0. Let's go below and have a look at this for the non-critical part. Down below here with electrical, 70 minus 60 gives us 10. So we have a float of 10 for electrical. 55 minus 45 gives us a float of 10. Notice that this 10 is common. It's a float that is shared along a single critical, non-critical chain. Okay. If plumbing were to eat 5 of those float days, electrical would only have 5 available for it to operate. So they're both chewing or feeding out of the same float bowl. If one of them eats it, the other one no longer has access to that. Right, in order to determine the critical path, you just look for the float that is equal to 0. And we can see that it goes through these tasks, 1, 2, 3, and then it goes up here, goes through 4, 7, 8, and then it goes down here to painting and tiling. So the critical path runs through 1, 2, 3, 4, 7, 8, and 9. Are there any questions on calculating either the float or the critical path? No questions. Okay. Let's progress. Right, we're now on to the exercises, doing exercise 5 and 6, analyzing the network diagrams, and exercise 7 is then for homework or for an assignment for you to do later on. So let's go down then to exercise 5. These are more earned value. Keep on going down here. Here we go. Exercise 5. So with exercise 5, I'm going to allow you to do this in your group. So do exercise 5 and 6 in your groups, working together, and share your answers. And I think for both exercises 5 and 6, probably 10 minutes will be sufficient. So here's the solution to exercise 6. You can check your work. Or is this exercise 5 that we're looking at? I'm not sure.
It's 6.
This is 6, okay.
That's a 5. You shouldn't say 6 on the slide.
Yeah, that's what I was saying.
Yeah, it's
I
exercise
think
5.
this is the solution. I think this is the solution to exercise 5, actually.
Yes.
Yep. Apologies for that.
Got
But
it.
just check it. You all checked it?
Are we happy?
Okay, let's go to the next solution to the following exercise. Is that the one for exercise 6?
Yeah.
Yes.
Okay. That's the solution to the next exercise. And we're now on to the final stretch for the day, which is project selection and feasibility. And this is usually something which is part of integration management knowledge
Philip,
area. Yes.
sorry to disturb, man. I was just having a brief discussion with the guys, on the network diagram, where I said, I remember when I wrote one of the exam back in the university times. So there was a time whereby in one of those network diagrams, they never even gave us a duration. So one had to even calculate the duration. So it was just 0 throughout. So I don't know if maybe during the exam, they can be nasty in that way and then just give you a blank diagram and say, calculate everything.
Okay, when you say that the duration was not present, did they give you either the early start or early finish, late
It was just
start?
nothing. There is a formula, there's a formula in one of the textbook. I cannot remember very well, but if not mistaken, it was into. I'll give it to you. So they just gave us 0, and then we had to first calculate the duration, and then that's when you start with.
Well, you have to have some data in order to calculate something. So if you're trying to calculate duration, you need to have perhaps either the early finish and early start, or late finish and late start. So the early finish minus the early start plus 1 or whatever it is, or minus 1. So that's how one can calculate the durations if you don't have durations. But yeah, I'd be very interested in seeing that particular option if you're able to share that. What I can say is that I haven't ever come across a question like that in the PMP exam. Most of the questions in the PMP exam, the network diagram questions, are fairly straightforward. In other words, they don't have something where durations are not present or something like that. One of the things that does happen is they give you a little fragment of a network diagram. So they don't give you the whole thing. And you then have to, first of all, be aware that it is a fragment, not the entire network. And second of all, work judiciously or carefully with that network fragment, because you don't know what came before it. You don't know the context in which the fragment exists. So that I have seen, and that's fairly common kind of question, is a fragment of a network. Of course, also calculating a critical path and working with floats. That's another common question. Great. So, I'm happy to look at that with you and make some comments. We can throw that back and forth between the two of us, and if I feel there's any applicability to the rest of the class, and if you're happy with that, I could share it with the rest. But I really don't think that the PMP exam is going to give you a question where you don't have durations in your network diagrams and then expect you to calculate that out of something else. Not that it's impossible to do that. It's just I've never seen a question like that yet. Okay, so project selection and feasibility. You will recall this particular diagram, which I mentioned was part of the ISO 21500. We have a strategy. We identify various opportunities that will fulfill that strategy. Out of those opportunities, we select one, which becomes a project, and that project will contribute to benefits for the organization. So the current projects may have been selected from several different alternatives. And the question that we have is, how on earth did we pick that project above other projects? So the project manager needs to understand the business case so that he or she can interpret it and review project feasibility. Project selection and feasibility includes an understanding of some of these basic mathematical formulae and equations. We're going to be looking firstly at present value. So present value is used to discount future payments to a present value, taking into account escalation. So if we have 10 Rand and we invest it now at a 10% interest, then in 1 year from now, we'll have 11 Rand. Okay, after 2 years, we'll have 12 Rand and 10 cents. Why 12 Rand and 10 cents? Because 10% of 11 is 1 Rand 10, which added on to 11 will give us 12 Rand and 10 cents. If we reverse that process and we say 12 Rand 10 cents in 2 years' time at a 10% interest is worth 10 Rand today. So 10 Rand is the present value. So the present value is equal to the future value multiplied by some discount factor. So if we're looking to find out, if we were given 12 Rand 10, we were told that that is over 2 years, and we were told that we're given a discount factor. We could then calculate the present value using the future value and the discount factor. So the discount factor's formula is 1 over 1 plus I, where I is the interest on an iterative basis, where n is the number of iterations that we're going to have. So in this case, I being the annual interest rate and n being the number of years. So we're saying it's 10% per year, and n is, in our example that we have on this slide, 2. Okay, so if we plug those numbers that are present on the slide into that formula, you're welcome to do that on your calculator. Just get your calculator. Then let's calculate what the discount factor would be for this specific example that we have. So if the interest rate is 10%, we add that to 1, and then we do the x to the power of 2. Okay, and then we do the 1 over x of that. I get a discount factor of 0.8 something. Do you guys get that?
Yes, Philip.
Yes.
Excellent. Right, so I is the interest rate or discount rate related to the interest rate at which the organization borrows the money. And so here we go. We're looking at the year 0. The discount factor is 1. Year 1, the payment is 1,000 Rand. The discount factor is 0.833. So the present value is 833 Rand. In year 2, there's a payment of 1,000 Rand, and the discount factor after 2 years is 0.694. This is at a discount rate of 20%. At the bottom of the table, you'll see that. So the third year, a payment of 1,000 Rand, and the discount factor is 0.579, which means the present value is 579 Rand. And so on until you get to the 5th year, when a payment of 1,000 Rand occurs. The discount factor is 0.402, so the present value is 402 Rand. So let me give you a scenario which explains this table for you in a really simple way. You have a brother-in-law. The brother-in-law has a TV. The TV is worth, when you look it up in today's terms, perhaps if you were to go and buy something like that at a second-hand shop, you'd pay about 4,000 Rand. So what you do is actually your brother-in-law is coming to you. He comes to you, he says, listen, I want your TV. You're like, that's fine. He says, look, I don't have 4,000 Rand with me, but what I'll do is I'll give you 1,000 Rand right now. I'll give you 1,000 Rand in a year from now, 1,000 Rand a year after that, 1,000 Rand a year after that, 1,000 Rand a year after that. In total, if you add up all of those 1,000 Rands he's going to give you, you can see that there are 6 of them. It'll end up being 6,000 Rand. And you think to yourself, and so just as an FYI, assume a discount rate of 20% for that money, and you now have to make a decision. Are you going to accept the 1,000 Rand now and 1,000 Rand a year from now, and have him pay 6,000 Rand in cash over those 5 years? Or are you hold out for another offer from someone else for 4,000 Rand? And by calculating that out, you see that if you're going to be receiving this money a year from now, that 1,000 Rand he's going to give you is only worth, in today's money, about 833 Rand. In 2 years, when he pays you 1,000 Rand, that's only going to be worth 694 Rand in today's money. And in 3 years, it's only going to be worth 579. So it works out that he's actually only paying you 3,991 Rand. So 3,991 is the present value of a 6-year cash flow of 1,000 per annum, discounted at 20% per annum. So the amount of money that must be invested now to fund those payments for the next 6 years. That's another way of looking at that. Right, so net present value. This is where we have a look at the present value of the costs and the present value of the benefits. Imagine for a moment you want to get involved in an ice cream business. So what you do is you go out there, you buy one of these vans that has the cooler in it, and those little vans that used to go around on the streets going do 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 do, and then all the children run out and they go and buy an ice cream. So you buy the van for 1.2 million, and in the first year of the operation of that van, you have to put down 100,000 Rand of capital in order to buy milk, buy vanilla, buy sugar, buy ice cream cones. And in that first year, you get sales, or you presume, and this is a calculation for the future, you presume that you're going to get sales of 500,000 Rand. In the second year, you're also going to pay out 100,000, and that 100,000 has been netted out to the present value, so that's why it's the same all the way through. And you assume that you're going to get 500,000 Rand worth of sales in the second year. The third year, the same. You're going to spend 100,000, you're going to gain 500,000. Fourth year, the same. Fifth year, the same. The question I have to ask you is, at which point does your project break even? So at which point do the costs equal the benefits? That's at year 3. So if you add up 1.2 plus 100 plus 100 plus 100, that's 1.5 million. And if you add up the benefits from years 1, 2, and 3, that's 1.5 million. 1.5 million on the left for costs, 1.5 million on the right for benefits. So our NPV, or our net present value, is the present value of the benefits minus the present value of the costs. If the NPV is greater than 0, then the project is profitable. The larger the value of the NPV, the more profitable the project is. Is this project profitable at year 5? Yes, it is. It is profitable. So if we were weighing this up against the project that is only going to give us sort of 100,000 by year 5, we would select this project instead of the other one. So what is the benefit to cost ratio? Again, we're going to be looking at similar things to this, but we're not going to be subtracting them to get a net present value. We're going to be looking at the benefit to cost ratio, or the profitability index. Same thing. So BCR and PI are the same thing. BCR is the benefit to cost ratio, which is PV over PV of benefits over PV of costs. And that is also the formula for the profitability index. So if we have a profitability index of 1, then the project's going to break even. If we have a project profitability index greater than 1, then the benefits are greater than the cost. The project is profitable. If the benefits are less than the costs, so the costs are more than the benefits, then we have a PI which is less than 1, and so the project is unprofitable. So when we're analyzing various projects, we want to go for the project which has the highest PI, the one that is going to be the most profitable. So again, back to the same question that I asked a little bit earlier. So the payback period is the time the product takes to pay for itself. It's the number of years to move from negative to positive cash flow. So if we look at this project with the ice cream van, at which point does the payback, what is the payback period for this project? It is at year 3. Okay, hang on, let's just go back there. So year 3 is the point at which that project pays itself off. And of these methods, this method, the payback period, is one of the most important methods for the exam. Oftentimes they will give you 2 different projects. They look so similar. They have the same PIs, perhaps the same PVs or benefit to cost ratios. And then you're like, well, okay, which one is better? And the thing that just separates between options C and D is oftentimes simply the payback period. That's the thing that is the one that is the method by which you would separate between the final 2 options, B and C. And we're always looking for the project that has the shortest payback period, given that the PI, the profitability index, is the same. Let's talk about return on investment for a moment. So return on investment is the expected annual profit as a percentage of the capital investment. Now, you may be looking at this, you say, heck, well, I just get confused when I hear all this stuff. What does return on investment really mean? So, and if you are a project cost accountant and you're looking at this and you're saying, wow, this lesson is so superficial, you're absolutely right. It is incredibly superficial, and it's superficial on purpose. What we're trying to do is we're trying to give you a high-level summary, like not at a very detailed level, understanding of these terms. And then this afternoon, or actually tomorrow morning, when I give you the homework assignment, I will give you extra reading where you can take this first introduction set of slides and you can now do a deeper dive into each of these items. So it really is not meant to be a comprehensive treatment of these different financial project selection and feasibility features or formulae. It's simply meant to be an introduction. And if you dive into the assignments that I give you and the extra reading, you will then gain a thorough understanding in due course. Right, so the return on investment is the expected annual profit as a percentage of the capital investment. So if we want to buy a shopping mall, okay, the shopping mall is going to cost 100 million to build, and the expected income that we're going to get from that shopping mall is 10 million per annum. So to find out what our ROI is, what we need to do is have a look at the expected annual income and divide that by the capital investment. So it's the 10 million that we're going to get per year divided by the 100 million to build it. And that then gives us a figure of 10% for this project. Then the internal rate of return. Internal rate of return is the value of the discount rate, which will give you a 0 NPV over the life of the project. In other words, it's the rate, the interest rate at which the project will break even. The higher the IRR, the more attractive that project is. The least sensitive to fluctuation in interest rate, and thus the one that is the most resilient to risk. The next method is the scoring models. These are used for scoring non-financial benefits, also called the ranking method, used to rank various alternatives. An example is for the 3 alternatives A, B, and C. So we're looking at various things that we're trying to decide between. Are are we going to, how much impact is this thing going to have on the increase in the company's market share, on the company's image, the optimum utilization of our workforce, acceptable risk level? What does it satisfy user requirements? Is it environmentally friendly? Is it convenient in operation? And then we analyze projects A, B, and C against each of those criteria, and we then weight it out. Adding them up at the bottom, we get a total for project A of 5, a total for project B of 7, and a total for project C of 6.2. So we'll select project B because it has the highest ranking for all the criteria that we are measuring. Any questions on that? Right, so the overall score for each project is a weighted average of the individual scores. Right, we now have an exercise. A mining house has a strategic objective to expand across Africa, and the following projects have been identified. Select the best project and assume that finances are not capped. So we have project A, which is located in Botswana. The PV of the benefits is 1.8. The PV of the costs is 1 billion. And the payback period 5 years. Project B is located in Zambia. The PV of the benefits is 3. The PV of the costs is 1.5, and the payback period is 5 years. Then the option C, the project C is located in Nigeria. It has a PV of benefits of 4, a PV of costs of 2, and a payback period of 8 years. Which project would you select? Please justify. I'll give you a minute or two in order to decide that. Okay, did you come up with an answer there? Let's see if your answer, let's see if somebody shout out your answer.
I got B.
Okay, Julian, you got B. Why did you pick B?
I worked at the profitability index for B and C is 2 each.
Okay.
B has a shorter payback of 5 years.
Excellent, well done. So the solution for the PI for project A is 1.8, B is 2, and C is 2. So B and C are both favorable, but B is better than C because it has a shorter payback period. Well done. Right, so now we have another exercise. We have 4 alternate projects, and we have to select which one is the better. So what I want you to do is, we've got 4 projects, A, B, C, D. Pick the one that is the most favorable, the one that is the next most, the one that is the third most, and then the last one that you don't want to do. So same story, evaluate them and decide which one is the best one through to which one is the worst one. Who would like to volunteer their most favorable project they've picked?
I said C, simply because both their PRs are the same, but the payback period for C is faster than it is for A.
Very good. So you chose C as being your first choice of which one you want, right? Which was your second one?
Was A.
than the reasoning?
Was because of the payback period. That's why I dropped it below C.
Well, firstly, because of the PI.
Yeah.
Because the PI of A is higher than B or D.
Yeah.
Very good, very good. Okay, and then the next one after A is, actually, let's go for someone else. Who would,
Okay.
So we're saying C is the first option, best option. A is the next. What would the one be after A? What's the next one that you'd go for? Anyone?
I'll go for B, and then
You go
the
for
last
B?
one is gonna be D.
B and then finally D. Now tell me, how many of you would actually pick D ever as a project? Because you're going to end up paying money in to this project, not getting money out, because the NPV is going to be negative 50 million. So you're going to have to put 50 million in order to complete this project. Not the kind of project that I would like to do, but yep, these kind of projects do get done, believe it or not, where you end up paying money to finish the project. How many of you can relate to this and say this has happened in your organization? You had to pay money to finish the project. Let's see. Anyone?
We're doing the Tongaat Mall in Durban.
You're saying it has happened, okay?
Yeah, the Tongaat Mall in Durban, we're in legal at the moment. So it's probably 3 million. Yeah, it's 3 million in legal costs. We haven't we're not halfway done. So yeah.
Yep, this kind of thing happens. In fact, I was chatting with folks not too long ago, a large organization involved in the Gautrain project, and they got deeply, they did some bad miscalculations in it and ended up losing millions on it. But they poured those millions in because if they hadn't, their reputation would have gone bang. So they thought, well, this is a good project. It's a high-profile project. We'll pay that extra 2 or 3 million in order to save our reputation. So this is something that happens from time to time. It's obviously not something that one would wish for, but yes, it does happen. Great, and we're on the final slide for the cost and computational theory that we've been doing today. And this is what we need to know for the exam. So we need to know how to interpret the NPV, how to calculate the profitability index, what IRR is, what return on investment is, the payback period, and the scoring models. We also need to understand the payback period calculations. Again, the number of questions that typically arise on an exam that have to do with project selection and feasibility and using these economic indicators, typically 1 question, maybe 2, but I'm telling you, many people that I've spoken to did not even have 1 question. So you will definitely not get more than 2 questions on this in the exam for this section on the project selection and feasibility. Great, so that's the end of the presentation. And if I look at our time, we are running towards the end of the day. So I wanted to give opportunity at the end of today to just have a little bit of feedback from everyone about anything. We can have a round robin, just open the floor, and yeah, please feel free to comment on absolutely anything. So yeah, it is a good idea if you have the time available to pre-read in the LibreArch file and to be sort of aware of the topics and the material that we would be covering in that day. Yeah, I think that is an excellent approach. And then to be able to, once you've then had the day's worth of teaching, to then take the further reading, which I send on various links and attachments, and to then do the deep study after that, and to tie the session, the interactive session that we have with that deeper reading very, very close to each other. So like, for example, now we've done computational theory. Don't wait for a week to do the reading on the computational theory. Rather try and do the reading for the computational theory this weekend. that then, you've got it in your mind already, and it's an opener for that material that you then are going to dive into. That's my recommendation. If no one else has any more things that they would like to share, we'll call that a day. And thank you so much for your active participation in today's class. And look forward to chatting with you next week, Tuesday. We may also add in an extra lecture. I've replaced Richard's participation with another lecturer, Dr. Andrew Holden. So we're probably going to have Dr. Andrew Holden paging in and out of this conversation. He'll be leading certain of the afternoons going forward, and I will be leading the other ones. So that's just a heads up in terms of where we're going and what to expect going forward. Yeah, and please, any of you who have any questions at all regarding anything on the course, please feel free to reach out to me personally on my WhatsApp. I am part of the group, so if you feel like it's too much to post it out on the group and you want to just speak directly to me, just WhatsApp me personally. I'll be happy to respond to you. I normally respond to my WhatsApps within about an hour, at most, at longest, sort of at the end of a session. So if you post something in the morning, by lunchtime, I'll do it. If you do it mid-afternoon, before the end of the evening, I will have responded. Thanks so much. Have a great weekend and all the best with all the reading and the studying that you're going to do for the PMP exam. I really appreciate all the hard labor and effort that you're putting in. The more you put into this class, the more likely you are of passing with a really, really good result. So thanks again for all the efforts, and I'll see you on Tuesday. Thanks, guys. Cheers.
Thank you.
Bye.
Bye. Bye.